Okay, hello everybody. My name is Wenyu from NTT Communications. Today it's really my honor to stand here to give you a quick update on one of the project in ONF, which is ODTN, the Open and Disaggregated Transport Network project. So please let me give you some background about the project. So basically in the transport network area, so people are very familiar with those kind of big box that show on the left. So one big box that is implemented by one vendor. So we don't know the detail inside the box. And moreover, on the northbound interface of that box, all the interface is closed and vendor specific. So as a result, the controller to control the boxes is also vendor specific. So in the traditional transport network area, all the networks is vendor locked in. However, what we expect is a total free and open network. So first of all, one idea here is to disaggregate the hardware as shown on the right. So we expect that the hardware could be disaggregated into different components. And we further expect that different components could be implemented by different vendor so that we can choose different vendor for different component in order to create our own customized box in this area. And moreover, we also expect the open interfaces, the open APIs which we can use to control the box. So what's the purpose of the open API is that we want to introduce an open source SDN controller for that. Because not only to reduce cost, but also we expect to add applications, and we also expect to develop our own applications on the SDN controller to customize our network and to add value-added services on the controller. So that's the background. So here, as is the vendor locked in the world. But we expect of a world that is created by totally open technology. However, currently existing community, as shown on the right, they only focus on their own specific aspects. For example, on northbound interface part, we have transport API, which we call TAPI. So they are focused on the northbound. And also ONF has the SDN controller, which is focused on the controller plan. And on the southbound interface side, we have open configure and open roll-down interfaces that we can use to create the system. And for open device, we can, some activities such as in the TIP, they have open line systems that is under investigation. But we see that there's no integrated solution in the open source community that can provide a overall one solution. So that motivated us to create a one-stop solutions for the whole system. So NTT Communications established the project and has been leading this project for almost 1 year, more than 1 year. And this is the reference design. So probably you're familiar with that. Different projects have different reference design to show the basic design behind. So this is the reference design overview of ODTN project. So you will see that there will be a SDN controller sit in the middle. And we have clear defined interface on the southbound and northbound. So on the northbound, we fully utilize TAP interfaces, while on the southbound, we utilize OpenConfig to configure the transponder from multiple vendor. And we still utilize the TAPI for controlling the open line systems. And beyond the SDN controller, we're thinking of, develop our own applications on the open source solution, such as the optical, telemetry, power management, restoration, protection, and so on. This kind of applications will be added onto the common platform, which is the SDN controller. So also today I would like to also announce another collaboration between ONF and TIP Candy project. I don't know how much you are familiar with the TIP Candy project. This project is aiming at create useful use cases in the converged packet and optical networks. You can see that this packet is being led by NTT and Telefonica, which is the two big operators, and they are defining common use cases in this world. And also, another purpose for this project is to add open source, to prove that open source solutions can be met with the architecture. So by positioning ODTN project and the open source solutions that we created in the ONF in the TIP project, so we can create a win-win relationship with each other to accelerate the final production deployment in the network. So this is a very promising collaboration system thing that is happening now. And this slide shows the current progress and next step. So we have a roadmap, so which we call phase 1.0, 1.5, and 2.0. So we have already finished 1.0, so in which we implement then the tested transponder provisioning based on OpenConfig interface. However, so we are now trying to expand the scope from only transponder to the open line system. So we are now utilizing the TAPI interfaces to control the open line system, which is being investigated in the TIP community. So the next step could be 2.0. So what will happen in 2.0? So we are thinking, first of all, to implement more function beyond the SDN controller, such as the path and config computation features and so on. And moreover, we expect to expand the scope of the project from point-to-point network to full mesh project network. So which is shown here in phase 2.0, the full mesh and transponder plus open line system. So that's the next step. As we know, not all the project is successful. We also facing with some challenges, especially if we are facing with multi-vendor disaggregated device. As you know, that lots of features are waiting us to implement among multi-vendor devices, and also we are when we facing with functions such as discovery, path computation, power control, more work we need to do, in order to cover the diversity of vendor solution. Also, regarding to the open interface, TAPI, as I mentioned several times today, so it's a very promising interfaces, but I think there's still some missing part. So that's why we are closely collaborating with the TAPI community to work together in order to grow with each other. And last but not least, when we see the product from the production perspective, we think that there's still some gap on the function of multi-device transaction and configuration state management and so on. So this is really a very important functions, especially when we think about putting those SDN controller into the production. So that's why we are thinking of implement these kind of features in ONS in order to meet the production requirements. But also I think it's not only the entity's efforts and not only the current members' efforts to build such system. So that's also we hold this session and to invite anybody who are interested in this area to join us and to contribute to the project, and finally to deploy the solutions to the production. So that's all for my presentation. Thank you. So no question, huh?